The following is a conversation with Vikram Maran. He is an AI scientist that works inside the technology and startup space. Throughout this conversation, I found myself being consistently challenged on technology and artificial intelligence and just development of the future itself, which are things that I thought I had a good handle on, but through speaking with him, I found out just how much more I have to learn about how much more I have to learn. There's so much to say about the human spirit of technology, engineering, development, and exploration. And speaking with minds like Vikram has continued to help me expand and appreciate just how much more there is to do in just the ingenuity of the human spirit. Human beings are capable of creating all kinds of amazing technologies that can be used for the betterment of mankind, but can also be used for things that can be considered malicious as well. Luckily, we as a human race are more prone to help one another with what we have with the resources that are available to us, and we are able to create a better space. Speaking with Vikram has only served to reinforce that part of my belief system. Now, my friends, I hope you guys enjoy listening to this following conversation as much as I enjoyed having it, and I hope you guys get to learn about technology and its many wonders that it provides to us. This is Vikram Maran and Rex on the Chasing Excellence podcast. Thank you. How are you doing, Vic?
I'm good. How are you, Rex?
Thank you. Very good. Thank you for coming on.
Thank you for having me.
Gotta shake every person's hand. Every person that's ever sat in that seat, I had to shake their hand.
Okay.
Or at the very least, give them a fist bump. All right. So you are a data scientist, right?
Yeah.
And you're deep in the. Can you tell me a little bit more about what it is that you do? Because I know through conversations in the past we've talked about AI, we've talked about technology, we've talked about like computer development languages, but and that definitely piqued my interest because technology, future, science are things that I really enjoy reading and learning more about, and I don't often have the opportunity to sit across someone who operates deeply within that field. And before we go too deep into this conversation, I want to make sure that I have a right compass on you so that I'm asking the right questions.
Yeah, it's a fair question. So my name is Vikram Maran. My background is in software engineering, data science, and in consulting.
Mm-hmm.
So to break that down, I spent about 6 years as a software engineer, and then I became a data scientist. So I come from the engineering side of a lot of these tech applications. I primarily worked in biotech and healthcare.
Oh.
And then I became a pure data scientist for a couple of years, primarily in telecom. And then for the last couple of years, I've been working in tech consulting. So that's been, it's addressed a swath of industries and roles. On one end, I've worked with investors in a PE firm, and on the other end, I've worked sort of as a, I guess, early stage CTO consultant sort of deal for an IoT startup.
Oh wow! So you've definitely done a lot across the board. Then it sounds like.
Yeah, I've heard this phrase called the T person in technology, as in you're a specialist in a bunch of things vertically, and then you're also a bit of a generalist in a bunch of things. And I think my career has been developing the vertical part of the T in the beginning, and then I've been acting more as a generalist for the last couple of years.
Gotcha. How much information do you have on artificial intelligence and robotics?
Robotics, I would say I'm relatively a novice at this point. I've done robotics competitions in high school.
Oh.
Within AI, there's a bunch of sub-problems that I've been pretty deep in. I'd say computational biology applications, predictive maintenance, and then some general AI problems too. I studied information science in undergrad, so I did a lot of machine learning modeling there, and also some classic computer science algorithm development.
Mm-hmm.
But I'm not an expert in robotics specifically. I know some general things about it.
Okay, but usually when I hear that phrase coming from a person that I deeply respect from an intellectual perspective, usually means that they still know more than 99% of the people out there. So I'll start with the most obvious question of as far as like AI development and technology is concerned, because I want this conversation to be kind of focused on like where we're going in the future, where we're headed, and what we can expect. Because I found like most conversations I have with people, they involve looking at the past, but I so rarely have a chance to talk about the future.
Mm-hmm.
All right. So as far as like AI technology, the obvious question that the most common perspective I hear from people is AI is taking our jobs, which I heavily disagree with, because I believe that AI is going to create is the artificial intelligence is the next industrial revolution as far as I'm concerned. It's going to create a lot of jobs out of there. It's automating away the mundane parts of people's jobs will allow them to be tremendously productive in other parts of whatever role it is that they function in, and it's going to allow us to become even more creative. Where do you sit as far as that is concerned?
I think I agree with the conclusion that it will empower creators. So one of my favorite tech strategists is this blogger named Ben Thompson, and he writes this blog called Stratechery. And one of his ideas is that tech is amoral, and I subscribe to that. I think AI is also it's an implementation of tech. It's a subfield of tech, and inherently it is amoral as well. It's basically it could be used for very good things. It could be used for very bad things. I think the positive side of what you said, that there are going to be a lot of opportunities for people who are applying AI to use it very creatively and for innovation. I think that's a new opportunity that is emerging. I also think there are going to be a lot of jobs that get eliminated, but not just by AI. That's just every form of technology has that sort of risk, I think.
Kind of like how the car eliminated the horseshoe.
Yeah, and the other thing is there are different opportunities from having an installed assumption of AI being more enabled. Same with computer science, same with software, right? In a world where software engineering is a norm, every specialization got its own tools that allowed its creators to build more things, more powerful things.
JavaScript allowed us to build better websites.
Yeah.
Python allowed us to build better applications.
Exactly. So I feel that way about it too. I'm not as much of a techno-optimist about it in the sense that I don't think it's all roses, but there are emerging opportunities, and I'm excited about those.
Yeah. There will be malicious people who will take tools and do malicious things with them.
Sure, but also, I mean, we shouldn't also just brush over the idea that a lot of people will probably lose their jobs slowly. That already happened in some fields, right? Like law is a good example. Law got disrupted, I don't know, 6 years ago, between a combination of software and the emergence of AI. A lot of NLP and applications and the development of infrastructure tech disrupted a lot of the work that lawyers used to do. So in the first place, it was a very competitive field, and then a lot of the work got disrupted by technology. So that's one of the tangible examples on the negative side. On the positive side, there's a lot of things, right? YouTube is a great example. They've created a creator platform, and there's a bunch of innovation both at the business model level that allows a bunch of different kinds of creators to onboard, new kinds of, and since one of the themes of the podcast is learning, it means that consumers who like different kinds of videos can actually have the full range through a platform like that. That's an intuitively AI-driven tool, actually, or an AI-driven platform in my view.
So Andrew Yang, I don't know if you're familiar with his works. One thing he talks about as far as the coming industrial revolution is if you studied the previous 4 industrial revolutions, there was a period of time where, kind of like what you described, where as technology was being disrupted, jobs were being lost left and right, was a time of a lot of turmoil and jobs lost, and a lot of like revolutionary actions were taken. Is the AI revolution going to be big enough to cause something like that? Because it kind of sounds like that's where we're headed based on what you just said.
So are you talking about Andrew Yang, the politician, or Andrew Ng,
the Yang, the politician, the guy who ran under UBI?
Gotcha.
Yeah.
Okay.
Because he talks about that in his previous 2 books.
Okay.
The War on Normal People, in which he said AI, which is an inevitability, will also create mass, not hysteria, but just a lot of disruption. And during that disruption process, before the new norm takes place, we're going to see a lot of destruction. Okay.
I mean, I think there's a potential for a lot of unrest, because, like you said, a lot of people could lose their jobs. But it won't happen in one wave. It'll happen as different professions get hit by this. And the other storyline we need to watch is what happens to those people, because some of them turn into creators and are basically examples of the new normal or the new opportunity.
The younger generation, for sure.
Not only the younger generation, I think that opportunity is there for anyone, right? Like the nice thing about a creator is basically they're good hubs of knowledge sharing for people who are similar to them, right? So I'm going back to the YouTube example. There are some people who are in their 70s who are talking in depth about a few things, few hobbies, but there are also hubs of information for people within that group.
And they have like 50, 60 years of life experience to share.
Right. Yeah. I mean, I'll leave that as an open question, right? Like, we don't know what will happen to the people who lost their jobs. Does that mean that there's very low odds for them to get reemployed into something that is actually a high growth potential domain in the AI-driven economy? I don't know. In a very precise way. As far as the unrest, generally we've trended towards less violent confrontations over time.
Yes.
So I'm a little bit skeptical of the idea that there will be pitchforks out, people going to war over this.
Yeah.
But that's pretty much an independent aspect, independent of AI as a source of distress.
Okay. All right. So let's bring this more to the technological side.
Sure.
So I can take advantage of your knowledge base. So I've recently been reading about different forms of space travel that are going on, especially with Elon and all these billionaires that are building all these rocket companies, which I 1000% support. Send us to space, develop new technology, break new frontiers. One thing that I recently came across is the idea of when we said the future astronaut is not going to be a human. It's going to be a robot that kind of, that we program to have our human-based information, because sending a robot into space is way cheaper. It's way, you don't have to worry about the loss of human life, and it could transmit data immediately from there back to Earth, well, as far as immediate can get. What is that going to mean for like space travel? Do you, because what I'm thinking is, as far as like with aliens are concerned, sorry, so we're going like way left field now, but because this is something I was thinking about earlier. As when we send like a robot into space and it explores space for us like 517 light years away and it's sending information back at us. How far are we away from developing that type of robot with that type of AI that can do deep space exploration? You can tackle that question any way that you want.
Okay, that's a very interesting question. I don't have a strong enough of an astronomy base to give you a very precise guess on any of it. I agree with the premise that a robot is a much better exploration mechanism than a human, for a lot of reasons. I mean, the first thing is that one of the innovations of software over the last 20 years is microservices and APIs. And
Webhooks.
Right. I mean, the big picture consequence of that is it's very easy for those systems to integrate with each other and build this nice big picture view of having independent devices gather specialized information, but then roll the information up in a way that is very strategically actionable, and you can see a whole map of what's going on for people who are managing the situation. You can even have robots managing the situation. That's one of the goals of current AI, actually, right? You have robots developing their own code and their own programs as part of their exploration mechanism. So I think the idea of a robot plus AI for the purpose of exploration, it's very promising, especially from a risk management perspective, like you said. The second thing is that one of the reasons there's this viral loop between the speed of innovation from like a Moore's law perspective is because there's improvement in the performance of like three components working in cycle together. There's the hardware piece. That's the dimension I have the least visibility into for space travel. Perhaps there's some huge challenges there that I'm not aware of at the ground level. Then there's the software and then the algorithms piece. So I think the algorithms piece is it's the one that can move the fastest because there's the least friction from a
because I'm not dealing with physical objects. I'm just dealing with lines and lines of code.
Lines of code and the application of the algorithms, right? So ideally, they would boil down to some simple things. But if there's not that, then you can use big data algorithms in order to develop these customized kind of sloppy models. In order to, well, not sloppy in terms of the outcomes, but they don't reduce into elegant formulas, right? They don't simplify in terms of the mechanism that'll solve the problems they're trying to go for. But that's my point, right? There's the software, there's the algorithms, and then there's the hardware. And the software I'm also very confident about because the world has been going through the software revolution for so long at this point, and we understand how to start something, scale it out, and then democratize it at scale, right? I mean, space travel is not capable of democratizing at scale right now in terms of infrastructure, and that's okay. It's at an earlier stage of exploration and I think growth of the market because at this point only the ultra rich can really go into space.
For now.
Yeah.
Yeah. Interesting. So as far as like software and AI is concerned, because that seems to be like where you're most comfortable with, as far as speaking. The most common use of software, of AI right now, of a true AI, is just suggestion bots that YouTube and Google and Facebook, Instagram use. Recommend you watch this or recommend you buy this. What are the other applications right now that exist within like most people's lives that AI is being used in that they're not aware of?
Well, sure. Actually, I think chatbots are a recent trend. I wouldn't say they are the majority case.
Are the chatbots like? Are you talking about like the ones that pop up like on the bottom of like T-Mobile, like, hi, how can I help you? Or
not only that, basically voice and language systems. That's the area that's been growing the fastest. For example, in the last few weeks, Google's been talking about its Lambda system, right?
The sentient AI?
Yeah,
oh
but
my God.
Even before that, there was GPT. There's been a lot of, model and technical system innovation in natural language processing. And since there's also been parallel development and growth within like language understanding due to the advent of Alexa, Google Home, all these sort of things, we're finally reaching a level of maturity from a product level of having these voice command systems that are working in tandem with AI developments, because more data means there's more opportunity to learn, but then there's also an opportunity to reduce the complexity of the algorithms, because you're actually going to learn the final patterns underneath them if they are there. Where are we going with this? Oh yeah, you were asking about use cases that people aren't thinking of aside from chatbots.
Yeah.
So I mean, the main use of AI is in mining out insights and then making smart decisions, right? And that comes sometimes it comes in unsexy ways. For example, like getting dashboards. Like right now, a smart home is a pretty good example of a system where basically you're giving the homeowner a really centralized view of all these systems that used to just work on their own, but you didn't really understand what's going on with each individual device, and then it's stringing all of the quantitative information you get into those components into a big picture map for you, right? So that's quantification within software, right? So you have quantification component by component, and then you have APIs and microservices coming into picture to build the map for you, and you can now control it.
But as far as I can tell, like applications like Alexa and Siri, they're still suggestion-based AI bots, though. At what point do they actually are they capable of making a decision, and carrying it out for us? Or am I asking too basic of a question?
I mean, I think there's a couple of we're conflating the problem statements, the problem cases.
Okay.
Like there's an old version of this problem called question answering. So IBM developed a system called Watson, which is based on the game Jeopardy. And the idea was that if you ask it a question, it should give back the most truthful answer. And that was the dream of, I'd say, the last 15, 20 years. This predates the recent work by Google and OpenAI for language models. But the goal there was feed really complex and uncertain and confusing data into a system, and then ask it some questions that humans care about. So one example is that within biotech, they used Watson for genomic data. So they fed it genomic data, and the idea was to ask it about like predictors of cancer or how likely what's the likely lifespan of this person.
Mm-hmm.
And
it's forecasting.
Yeah, it was doing its own crunching in the background in order to answer that question as honestly as possible. Mm-hmm. Within biotech, it did not work at all. It was a big bust at that time.
Why is that?
I'm not sure, actually.
Okay.
Yeah, I mean, I know what happened within the company I worked in. Mm-hmm. I think one of the challenges is just integrating very different kinds of data. Mm-hmm. Because fundamentally, data science on its own, inverting the question, right? If you're what is the best way to actually produce a valuable model for decisions? Mm-hmm. And you pit a human, a hybrid system, and a pure robot towards those tasks from a bake-off perspective, from a competition perspective. Mm-hmm. The combo seems like domain specialists plus machines. It's the hybrid one.
Yeah.
So by improving the way pure AI, the machinery works, you're basically improving the second case of a hybrid.
Hybrid being like a functioning relationship between a human and an AI working in tandem.
Yeah, but to be clear, I'm saying the expert is a domain expert, not a data scientist.
Domain expert.
As in, like if you're looking at GIS data, a person who's an expert in GIS mm-hmm. is more likely to be the right expert to pair with that system.
Okay.
Yeah.
So developing like AIs that pair best with a person's natural ability so that they could excel at whatever job it is that they're going to do?
Not natural abilities, because when I say, I'm trying to contrast this with the idea that a data scientist, because what is a data scientist? They're a general purpose scientist, right? They're mm-hmm. agnostic to the kind of data that comes in, but they try to find the patterns and orient the framework for experimentation mm-hmm. in a way that'll help them solve the goals that you disclose up front, right? But that sounds like that's a very generalist way to put it, right? But basically, if you apply them to problem A for apples and problem O for oranges, mm-hmm. the person who's been working on A for apples and O for oranges usually already has a pretty good lay of the land, even if they don't understand the data science piece of it, right? Mm-hmm. And so that's what I'm saying. Between the expert in data science and the expert in the domain, the expert in the domain is often a better person to pair with the system because you can abstract away the data science expertise into the AI system.
So like if I had a AI that understood quantum physics, I could pair it with Michio Kaku, and together they could finally solve string theory.
Yeah.
Wow.
Something like that, yeah.
That'd be really cool. If we could solve string theory, then we can get into gravitational propulsion systems.
Yeah, actually those sort of applications were one of the drivers of the creation of computer science. It was applied math, right? Yeah. It was computers plus physicists trying to solve their own problems. And then while they were on their downtime, they realized that computing democratized and created a whole world of innovation.
Yeah, because I think it crunch numbers while I can't, and crunch it unbiasedly.
Yeah.
Mm-hmm. So I know. So we briefly mentioned the Google AI and the engineer who said it was sentient.
Sure.
Your perspectives on that?
I haven't. I've followed that story a little bit, not in depth. Mm-hmm. And I started listening to an interview by the engineer himself, and he was talking about his testing framework and how he was running the test for Sentience, and they were kind of modern adaptation of the Turing test. Mm-hmm. I guess before we go into it, I'd like to point out something. I avoid the word AI because it's a very vague term, not just in common parlance, but even in its technical definition, I find as a very vague term compared to any of the other disciplines.
Well, AI is just if I'm understanding correctly, you could let me know if I missed this by a mile. AI is just like a field of study that which is understanding computer-based decision systems, and that can mean a lot of things. Whether you code an if statement into like using JavaScript, or if you're using a neural, like a machine learning program.
I think that's more specific than how it is actually defined.
Oh, wow.
Yeah, so it stands for artificial intelligence, as you know, but it initially was defined by the Turing test. The idea was that you build
the Turing test?
The Turing test is this idea that if a person was talking to a computer program, on a terminal.
Can you tell if it's an AI?
If it's sentient, right? But sentient is it's a very tricky idea.
How do you define sentient?
Exactly. So he was pointing. The engineer was pointing that out. This was a debate that was happening in the 1920s. Like there's a bunch of philosophy, cognitive science research, and a bunch of other things that developed a domain around how do you define sentience. And then there's also kind of a cynical view of it, right? Because the way humans define sentience is also very anthropomorphic, right? Because most animals are sentient, right? But they won't exhibit it from behavior perspective in the same way a human would.
Does a dog recognize that it's a dog and not a human, for example?
You could do that, but the example he was using was does a self-driving car consider itself sentient? It's self-aware that it is a car on the road, right? But it can't communicate in a human way that it is a car on the road. So my point is that it's the language, the qualifying language for artificial intelligence, unlike machine learning or computer science and things like that, are so vague, even at the most technical level definition of it. So I try to use the specific use cases. Like when we're talking about self-driving cars, I prefer to use that natural language, understanding that is also something specific. If we use AI as it is, I think it's just a moving target. And it's always colloquially spoken of as whatever is just beyond the solution space of an active subs problem, right?
Gotcha.
Actually, what were we talking about?
We were talking about the Google Sentience.
Yes, yeah. So that's why I was bringing it back to sentience, right? Sentience is a very fuzzy term. Actually, even now, right? It's been a fuzzy term for 100 years, basically. So far, I kind of sympathize with the engineer from a technical standpoint. There's effective sentience, and then there's sentience that matters in really high detail for some people. It's kind of like your mileage may vary for something you're a hobbyist at versus an expert at. You and I both do sports. We care about VO2 in the sense of like, will it allow us to do our sports well, right, on a regular basis? But if you're comparing it to a cyclist whose VO2 threshold basically defines whether they can do it as a lifestyle, it's a different world, right? So for most people, I think the engineer's definition of sentience is good enough. I think he's kind of right.
So what did he mean when he said it was sentient then? Because
as in, if you can have a realistic conversation with Lambda.
Yeah, I've gone on a few websites and I've talked with a few.
Yeah, so it's
eerie.
Right. So that's my point. It's programmed in a way where you can there's really very little exclusions of what Lambda would say compared to what a human would say, right?
Yeah.
The space of what it can't say is politically defined, right? So I think for the world, right, the effective definition of sentience, it does solve it.
Okay.
It's a very politically loaded thing to say that in this country, but yeah.
But it's not thinking in terms of I'm an AI, I'm alive, and I'm aware of my death.
At least it's been trained to speak about it in an emotional way.
Yeah.
Yeah, but I also say like the reason I brought up the mileage may vary point is that there are specific use cases in that conversation that are actually very important to some people, right? Like a cognitive scientist or a neuroscientist. I worked in a neuroscience lab when I was in high school, and they would care about how the animal defines itself, how it behaves. All those things matter very deeply, right? The way they express themselves, and then how that maps to what they actually do.
Do animals have a sense of the future, of the past?
Right.
You know, we don't actually know that. We assume we know that, but because it makes me think of the experiment that they do with the dog. You know, the dogs seem to always know what time their owners get home, but then like, is that because they're just conditioned to know? Do they have an internal clock that says, all right, it's 5 o'clock or whatever that means in dog time? That's what time my owner typically gets home, or is it something else that they just recognize that when the shadows on the wall are at this specific time, that's what time the owner gets home? So, are dogs sentient then?
Yeah, I think most animals are sentient.
Okay.
They have different sensory systems as well, right?
Yeah.
Like they have smell and other things like that. So the way they perceive a time change or the circadian rhythms, the things that most animals have some basically they react to, right? They do it in their own way, right? And how do we tell that they're sentient? It depends on depends on the input, the way we can see the reaction to inputs, and then how they express it, right? And the way they express it currently is defined in a very human language form, at least as far as these models are, the models they are discussing is concerned.
So as far as like animals and just machine learning programs are concerned, and human intelligence is concerned, is one of the ways that they measure intelligence is by the complexity of the vocabulary, complexity and volume.
Okay.
Like the average North American male and female in their mid-30s has a vocabulary extending to about 5,500 to 7,500, depending on their intellect. Obviously, higher vocabulary typically equates to higher intellect, according to what I've read.
Okay.
They've been able to, as far as I'm concerned, establish that dogs and animals can have a vocabulary of up to like 15, 20 words.
Okay.
And the smartest like primates, like the chimpanzee, can have a vocabulary of up to 65 words.
Okay.
Which is pretty extensive, pretty impressive, because you figure like most babies understand like 25 words.
Yeah. Okay.
As far as like machine learning is concerned, they haven't defined that yet, as far as I'm aware. Is there a reason that they don't define machine learning through vocabulary-based systems, or am I misunderstanding something here?
You mean for the problem of judging sentience?
Of judging intelligence. And
for judging
sentience.
intelligence.
Yeah.
So I would say this. I'd say a couple things. First of all, the language-based, the intellect-based, the idea of language correlating with intellect is more of a Western idea than an Eastern idea, in my opinion. We're a very literary culture, whereas I think in other cultures, the idea of intelligence shown through action, or intelligence shown through nonverbal communication.
Pattern recognition.
Yes, is perhaps stronger. So at a philosophical level, maybe that's a gap. The second thing is, machine learning models would have first biased towards language, because language is an easily encoded stream of information to start building your models.
Yeah, like dog, cat, tree.
Yeah, and on top of that, you can encode in their vocabulary. And on top of that, the kind of modeling techniques we use lend really well towards translating words into weights, right? So a lot of the linear algebra based, both the neural network cases and the I guess the eigenvalue based, the matrix decomposition based cases play really well with language in terms of like a written vocabulary. So that's the starting point of how these models were built. So there's a bias there, right? That means that all these other streams of information that could display intelligence are added in after the fact, right? They're added in bit by bit. So that adaptation of learning by voice is one more way to add a huge dimension of information about how a person or an animal may behave that you can now incorporate into this model. And then now we have video, right? So there's a lot of computer image segmentation and processing adaptations that you can encode into language, because now images and videos are being tagged. YouTube uses a lot of that too.
Yeah.
So now you can put them all in the same model as words, or as weights that are derived from words. And so those are three streams where you now have the opportunity to derive intelligence from.
What exactly is weights? Because I've heard that term a lot, but I kind of have an idea on it, but I want to get it like solidified.
Sure. So in this weight, when I'm talking about weights, I'm kind of vaguely talking about ranking the importance of different factors, right? So
this holds more weight than that.
Yeah, exactly. So I'll give you one of the classic and simpler cases. Say you are Spotify, right? And you have a catalog of users and you have a catalog of songs. So you use this linear algebra technique called singular value decomposition underneath, and it'll take that table of users against the songs, where the values might be the amount of times they played each of those songs, right? They'll be able to extract out weights using this technique that tell you what the most popular songs are. And the most popular features of those songs are, and I guess even the most popular users by this shared weight by using this kind of technique.
And then it could tell that a 35-year-old male from Tampa, Florida, well, maybe not that. Well, this law is about making profiles that specific these days, but it could tell like 35-year-old men from a certain area tend to like listen to Papa Roach a lot. So that so Papa Roach holds a higher weight if you match this specific profile.
Exactly.
Okay.
Yeah, and there's different. Each model kind of has its ways of deriving the weights of the factors you put in. So yeah, there's that too. That's why I was bringing up weights.
Gotcha.
And what was the bigger question we were trying to get at?
Well, we were just talking about like the different ways the AI
can detect sentience.
Detect sentience and intelligence, and how we decide, and how we as humans and creators and engineers decide that.
Gotcha. I mean, I can't tell you in a detailed way because that effectively means run a model and then look at the results and understand what the state of the truth is. And I think at the moment, like a company like Google probably has a pretty good idea of that, because precisely because of the way search is built on AI, and also how YouTube is built on reducing video and audio into a word-based model, right? So I think advertising companies like Google and Facebook are actually probably the best sources, just from
they have all the information.
Not all the information, but just their business model aligns with how you would design an experiment in order to answer that question.
Can you go into that a little bit more? I'm curious.
Yeah, so advertising business models, right?
Yes.
Have you heard the term like vertical versus horizontal AI?
Yeah.
Okay, so Google and Facebook, because they're ad companies, ad companies implement horizontal AIs. They string together a bunch of different data verticals horizontally. They string them together into like a singular data set. That's the idea of a horizontal AI. So they have the means to do all this kind of unique experimentation that looks at whether there's patterns between really unusual features, right?
Such as
does your YouTube activity, your YouTube video viewing activity relate to your health purchases?
Interesting.
That might not be a really good example of a contrast to a vertical AI, but I'll give you an example of vertical AI as well. Biotech is actually really good. So like I said, I work for a cancer diagnostics company. What they did is that they took a tumor sample or a blood sample, and they ran a genome sequencing test on it, and then you got your genome back, right? So that's a narrow AI. The data you get back is narrow because it's one kind of data. It's genomic data derived from one source, and it's about one person.
And unique to that specific individual.
Yeah, so you could find information about that one individual in both data sets, but the way you make an insight is different, right? So you're going deep into one style of data in the vertical AI, whereas in the horizontal AI, most of your innovations or your unique value adds are by connecting different parts of your data set.
Gotcha.
Yeah.
If you're allowed to talk about it, I'm definitely curious as to like the work you've done with the biotech system and where we're headed there, because as far as I'm concerned, genomic science is a future that has a lot of potential. Like imagine being able to just adjust people's DNA and like just spotting the ones that have like the specific DNA that creates, syphilis or whatever other disease, and they can cure cancer before it even starts, or even for like more like commercial purpose. I want to have a kid that's 7.5 feet tall and has like the body of the Rock.
Come on, don't go eugenics. Yeah, I can give a couple of opinions on this. I mean, the company I worked for had a lot of. So in the U.S., the first company to create an innovation CRISPR was the Broad Institute. And the Broad Institute actually sourced a lot of people in my company. It was a startup called Foundation Medicine. And it's definitely a hugely promising area from the gene editing standpoint. But I think there's also a huge opportunity to impact just from democratization of what was already being done previously. Like I was talking about cancer diagnostics, but I'm really excited about the idea of the whole world getting access to whole genome sequencing. I mean, we're starting to see that a little bit with what 23andMe and Ancestry and all these people are doing, but I don't think they're doing really small parts of your genome, and they also come with like U.S. privacy guarantees, which are kind of shady in my opinion. There's been 23andMe has had data leaks before, and I think it's a horror show scenario of insurers basically paying hackers to gather that data. They're the people who would actually benefit from that. So I am concerned from a privacy perspective, but on the other hand, if you get your whole genome sequenced while you're young, or periodically, because the cost of whole genome sequencing is going down. It's something like $500 at this point. Yeah. Wow. So that's incredibly powerful, right? If you just there's a bunch of things that are very exciting about that. First of all, if the costs go down and most people can get it, that means you'll end up finding a lot of the primary risk areas for yourself, right? And if there's a way to guarantee your privacy from that sort of thing, that's enormously empowering. The second thing is from a business side. I think consumer-driven healthcare is a trend that even the U.S. is catching on to. It's been more of a trend in Asia and other areas due to their healthcare model. But like you see that already, right? We're all wearing wearables to track our heart rate on a more frequent basis. That's how your biometrics are actually useful to you. You don't need to go to a doctor to get 80% of their information. If you have things at home for like a reasonable price. Right now I think in the US it's premium price mostly. It's a little bit expensive.
I can get a Fitbit for about like $60.
Right. But even a smart scale, right? Like in the US it's mostly by Withing, and Withing is $100 or more. Whereas in Asia it's by Huawei, and it's $30. But my point is, say you have like a lot of the healthcare telemetry and stuff just easily available at home or at your friends or something like that. That changes the equation so much, because if you get like 70% of the information you get from a medical visit accessible to you easily, where you can check in more frequently, you're more empowered than you are in the old model of going to a doctor's visit every 6 months or a year.
If I had a machine at home that I just stick my finger on it, pricks it, gets like a 0.5 millimeter of blood, and it could just check my my testosterone levels, my other hormone levels.
Right.
And that enters into a database that communicates with the amazing pharmacy company that Amazon's building right now. I could get like unique specific drugs that are catered specifically to me based on all of that.
I mean, I would say healthcare and pharma are not easy nuts to crack, especially from the business perspective. Well, I don't see how the cost will necessarily depreciate out, and most of the investments by the big techs into the pharma side of things have been slower, because it's more of a network and relationship based business, as in there are big hospitals, there are big partnerships that are there. So it's not something that will be disrupted by technology, really. But I think in biotech and healthcare, in terms of the sensors and the wearables and the data telemetry, like I think there's a lot of opportunity in terms of just reducing the cost so that a lot of people can have access to that.
So the emergency services, those costs that's not going to be disrupted. But as far as like the day-to-day healthcare, that's where you see the future is.
Can you give me a big emergency service? What do you mean by this?
So I accidentally ingest rat poison, and now I'm in the hospital. I need ER services to take care of me.
Yeah.
Because something like that would still be heavily tied to insurance companies,
exactly.
Still tied to hospitals, still tied to a lot of bureaucracy, versus a day-to-day, like a month-to-month checkup of just want to make sure I'm okay with the doctor.
Yeah, my point is that innovations on both ends from technology are happening. I'm just saying the rate of improvement in healthcare compared to like biotech or health IoT is going to be slower, because the bottleneck there is the hospital system, right? It was built with this level of complexity because it's such an important need. There's a lot of permanent demands that are there that system was designed to solve. And like technology right now basically can only disrupt things like the initial access point, right? So you get rat poison if you have an app connecting you to your insurer or your doctor. That is one way to disrupt some of the typical lag you would expect. But on the other hand, like once you start, you're basically in the same. You're going through the same pipeline of activities, right? Whereas in the health IoT thing, I'm talking about inversion, right? You're not going to the hospital at all. You're getting this information, and sometimes just having a specialist within one of those streams of data or a few streams of those data will be more helpful to you in terms of preventing things and developing power and credit along those things than having humans in the loop for that, or I guess having doctors and nurses in the loop, right?
So I have an interesting scenario that I want to run by you, because I was talking to a friend real quick. His sister works in the insurance company, and the insurance world is, because it's kind of tied to what we just talked about. The insurance world is tremendously complex. One of the biggest bottlenecks there is the underwriters. You still have like humans still entering data, still running regression analyses left and right, trying to filling out paperwork by hand. And because there's thousands of these per company, whether you're large or small. I think Geico has something like 50,000 underwriters per state or something like that. It's something just unbelievable.
Yeah.
Why hasn't technology disrupted that yet? Because I feel like one of the biggest costs of insurance is just maintaining the system.
That's true.
Which is expensive. And if I could turn one...
Because it's not a technology problem. It's because the constraint is regulation, actually. There's two problems. The first is that there's too much disintermediation at the provider level. Like you said, there's so many different underwriters who work for a bunch of firms, right? And each of them basically offer usually the same thing. And they are only competing on some of the surface, the face value of the price, right? On the back, though, all the deals end up repaying somehow, right? They're doing some LTV on the lifetime value calculation on the back in terms of how much it would cost them to actually provide those services and how likely those will actually get hit if you sign into that plan. So in the U.S., you have a lot of inconsistent regulation between the states, between the cities. And then on top of that, they never really get simplified, right? I mean, you can talk about most tech reforms, but having the ability to simplify it into one coherent standard is really important, just at the standards level, not even the tech infrastructure level, where a lot of people talk about like standardization of EHR and things like that. But my point is that the biggest hurdle is actually just having this regulatory consistency around the framework in a way that allows it to scale. And in other countries, it's actually better. Like I lived in Singapore before. The underwriters move a lot faster for whatever reason. And when I came back, I was kind of surprised because like we need insurance in a lot of different categories in the US. I think in most countries, that's how it is. As you age, you need more categories of insurance.
Yeah, your risk increases.
Yeah, but you're not dealing, as a consumer, you don't have direct access to a customized risk plan, right? And that's weird because there's a lot of, that means that you can never you can never synthetically buy a certain package of insurance that'll address what you're actually worried about. So I think there's an opportunity there, but it's I don't think there's an opportunity for technology to disrupt that.
Huh. You really got me thinking then, because just from talking to him and to her through him, it's
just one more.
Like if we could just turn like one underwriter and make them with the efficiency of like 100, we would like slash the cost of just insurance upkeep through the system by like over 60%. It's crazy.
Yeah, just full disclosure, I work for a value-based health insurance B2B company.
So you know this area through.
A little bit. So value-based insurance is also one of those innovations, right? The idea is that they act on the behalf of insurers to connect all the information that goes into managing a patient over their life. So the idea is one of the areas within the healthcare system. It is a good day, yeah. Okay. Yeah, so one of the areas where both the healthcare system and insurers get lost is when a patient comes into the hospital, because when they come in, they might come in for condition X, that's an emergency, or condition Y, which is not an emergency, and they might do it all over the country. They might be forced to do it out of their incumbent in-network systems and things like that. Mm-hmm. So value-based healthcare created a centralized owner, actually, in the insurer, because they're the ones who pay for it, and by doing that, they're able to give prices on what the outcomes for patients were, based on whether they went with system A, hospital system A versus hospital system B, what the true cost of like going through an operation at hospital system A versus B is, and that way they can back out and help patients avoid some scams, basically.
So improving technology isn't going to help us lower healthcare costs, then?
It is, but I'm saying the bottleneck is more at it's at a regulatory level, and then also at the network level. But the network level is less of a big deal than the regulatory level.
Oh, I'm 100% okay with getting rid of regulations in a lot of different fields. It's made some of my work difficult in the construction world.
Okay.
Yeah. We'll get into that some other time, because technology is barely inside smart technology is barely inside my world.
Oh yeah?
Right now. Yeah. Oh,
okay.
There's a huge opportunity there. We'll go into that some other time.
Yeah. Sounds good.
Yeah. Okay. Wow. No, you've given me a lot to think about as far as just machine learning and where we're going with it, and as far as
I'll give you I guess one more thing to think about.
Yeah.
So far we've talked about biotech and healthcare.
Yeah.
So I would say they're inherently kind of high impact cases on the average human life, right? Everyone is going to live and die, and there's going to be challenges and problems related to healthcare. So access and the ability to efficiently get care is very important. On the other extreme, I would also like to point out, like there's cases where there's a tiny incremental technology that can be accessed by everyone. Mm-hmm. So I would put my telecom experience on that side, right? So I did machine learning at a telecom, and that's that they learned in a similar way to the horizontal AI companies I talked about. Mm-hmm. They learned about how people use the internet and how that's evolved over time, right? We use a lot more streaming services at this point. So there's opportunities to actually create value even in there. Because there's such a large, everyone uses telcos and ISPs as the base of their internet activities.
Interesting. So speaking of telecom and everything, one thing in my company we have a sales force of about 20-25 sales reps on the phone all the time, like they're phone sales reps. And it's a lot of inbound. One thing I'm very conscious of is the development of technology like deepfake, and ability to just copy faces, and also to just take a single sentence that you and I say, and through that one sentence copy not only just our mannerisms when we speak, but our character as well. And it's frightening to me. And I have it in the back of my mind that in 15 years, I don't even need a team of sales reps anymore. I just need like 2 or 3 AIs just running 24/7 that have the tonality of my highest, of my best sales rep, just on the phone, constantly selling nonstop. Is that a reality within our lifetime, or am I overestimating our capabilities technologically?
I have no idea. I mean, I recently worked in sales, and I'm a very well, I'll give you 3 things. First is that I've worked on the AI for telephony systems, so for the telco, I actually worked on a case where we were trying to find out which sequence of like redirects got people pissed off the most, and then which ones seemed to create the most happiness. That wasn't even dealing with humans to start off with, right? But it was helpful to understand like the telephony systems, which were built on this idea of automation, increasing your sales volume. it actually bifurcated your audience, right? There are people who are patient enough to go through all of that and then finally get the help they need. And then there's people who got exhausted
They
by
just
dealing with
mashed
it,
the 0 button trying to get to an operator.
or they gave up, right? And a lot of those people are active customers or they're prospective customers. So I would say that's one of those systems where it's not just in telco; it's in it's a sales channel that was built on the idea of automation, which galvanized the behavior of your leads and your active customers even worse. So I would challenge you to think of it a little bit differently in that sense.
Mm-hmm.
The second thing is, depending on the field, scale doesn't always help, right? Like in BD and partnerships, ultimately they look at the model of the management of those accounts gets aggregated to specific humans talking to each other at a high level, right?
Mm-hmm.
So you're talking about your 15 sales reps. If you're the manager of them, right? There's times where you'll talk about partnerships with other companies that are kind of complementary or potentially a consumer or customer,
Mm-hmm.
right? So it might make more sense just to optimize the interaction between you and the other partnerships person,
Mm-hmm.
rather than focus on on scaling out that one person.
So pretty much like, so if I'm understanding you correctly, the way I should be thinking about this is have a recording of the phone call my sales reps have with the prospect. As I listen in on that phone call, I can pick out keywords here and there that indicate the quality of this conversation and the likelihood of the sales lead moving to the next step.
Yeah, that's one way to do it.
That would be a better application of the machine learning software.
Yeah, that's a human in the loop way. And actually, I think that's also the default way that companies like Salesforce are trying to do it.
Mm-hmm.
The idea is that you have CRMs and systems that track how the interaction went.
Mm-hmm.
And that's the best, right? If they're the systems that capture the underlying interaction in the highest fidelity are the ones which offer the best learning, in my experience.
Mm-hmm.
Because, yeah, first of all, you a lot of top-down systems, like the two situations I talked about, they're inserting the biases of the human into how you even perceive the interaction.
Mm-hmm.
And over time, a lot of those biases just get disrupted by technology, or those biases prove wrong, right?
Mm-hmm.
The majority of your industry may love to make deals over the phone initially, but it might be video calls in the future.
Yeah.
So having a true picture of the initial interaction is more important than how that was recorded by the person manually eventually, right?
Mm-hmm.
Because the way that person recorded it encoded some assumptions about how the pipeline would look in the early days. We're getting kind of off task, but yeah, that was my point. There's three ways you could have gone about that problem, and you talked about like the way of recording it and then using the big picture.
Understanding the quality of the conversation.
Yeah.
Okay. Interesting.
And people do automate pieces of the conversation as well.
Yeah. Well, yeah, because most companies like Salesforce, the first conversation you have isn't even with a human. It's with what is your name, where are you from, and what are you calling in for? And and that gets fed to a person on the line who reads it and says, okay, I can send this to that department, to this department, and and even that part is automated now as well.
But I mean, let's imagine this as a real world, like what is the ideal product solution, right? So a lot of that boilerplate thing, I'd rather the person on the other side of the phone doesn't actually have to answer, right? Mm-hmm. Maybe they have a service that's specifically for that, mm-hmm. and they can give you some code that just allows you to access that service, and that way their system and your system talk mm-hmm. without having to spend minutes doing data entry, right, or data or voice transcription of your recorder against their voice, mm-hmm. right? So that's a lot of the more standardized pieces of it. I would like, in my ideal world, I would just like for there to be microservices that kind of solve this, that map to each side of the interaction.
I mean, if we're talking about my ideal world, is what I envision for at least the company that I'm working with right now is a person can scroll through a website, and based on their behavior on the website, it's already generating a profile for them, like where their eyes look, where their mouse lingers, and then by the time they even click on like call service, like everything attached to that IP address is sent in, and there's already a profile built out.
Gotcha.
Yeah.
The thing is, click-through data, what you're talking about, is the source information, is very noisy.
Yes.
And
there's a lot of regulation against that.
It's not regulation. There's actually an industry based around making predictions based off of click-through data. They're very hit or miss because click-through data is not that informative. That's really what it is. I mean, they basically milk the most they can get out of that. And it's going to get sloppier because of the identification stuff that's come out recently. It might, the advances in the modeling might improve that.
Yeah. Apple's already made it very difficult for companies to collect data on their users nowadays.
Yeah.
Awesome. All right, so I did tell a couple of my friends that I'm bringing on a data scientist who knows AI, and one of the things that they really wanted me to ask you is, and I'm not even sure like how I feel about this question, but I'm just gonna ask it for his sake. He's very, very adamant that as intelligence, as technology improves, the very, very first people to go are going to be CEOs because AIs are, as they exist right now, are decision machines. And I know you hate the word AI, but I don't know what else to say right now.
Yeah.
The first people who are going to be gone are CEOs because the AIs would just make better decisions than the CEOs can. More informed, more with deeper thought. My counter argument to that is the way our machine learning programs are running right now. Like if I look at like a program like AlphaStar or Tesla's driving neural network, they're programmed to do one thing, which is either play StarCraft, play chess, drive this car. They don't have the ability, as far as I'm aware, and let me know if I'm wrong, to do anything else other than what they were taught and trained to do, making it very difficult to replace someone like a CEO of a startup company or even a Fortune 500.
Gotcha.
What do you think about?
Okay, so I guess there's 2 points I'd like to make. The first is from a leverage standpoint, as in what would drive an AI adoption. It's the decision making of leaders. So I think high level leaders are the last to go because AIs are currently most of our business. There are many businesses that are either service oriented or product oriented. And who does what's the entity that does the final sign off on decisions, whether AI is part of it or not? It's humans. From a legal perspective, right?
Yeah.
Because that's how entrepreneurship is. Until we get to a point where there's an AI entrepreneur, I don't think there's a case that the CEO will be disrupted, because you need humans to absorb so far, you need humans to absorb the risk. I mean, I would say that there's also quantitative trading, where to an extent a model does have some culpability, but all those models are owned by the trader, right? So there's this moat in the sense that there's an owner who is necessary to hold the bag for the level to which they build the AI for. So I think the two people who are empowered a lot by AI are decision makers and technical experts. I would say you don't need as many generalists in the middle, in my opinion. That's what it does. It bifurcates it galvanizes the kind of staff that you would need to get a venture done.
Right, because the company I work with, this is one person very pivotal to our company. She does about 5 times the amount of work that she normally would be capable of.
Yeah.
Because we've poured tremendous amount of energy into automating half of her tasks.
Yeah.
It types up emails for her, where to the point where all she's doing is copy and pasting.
Gotcha.
So so instead of spending 5-10 minutes typing up an email, she spends 1 second hitting a button.
Yeah. So that's my first point. And the second one is about horizontal versus vertical AI again. The example you were talking about, all these AIs with a single goal, they're vertical AIs.
Yeah.
But then there are also there are horizontal AIs, and I would say the language models are a good example of them.
What do you mean?
As in, within something like cars, right? It's really important that those systems follow something like an API or microservice architecture, meaning each of the components actually has a specific job to do. You don't really renegotiate the contracts of those jobs because otherwise the whole system, the integration of the system gets compromised, right? Whereas a lot of companies that are horizontal companies at the heart, like I said, advertising is a horizontal company. Most platform companies are horizontal companies. Even the way the company prices kind of implies what sort of company, what sort of AI could actually be more suitable for it. Yeah, that also has a bearing on it. If it's a horizontal company, that means there's more integrated big picture data or big picture opportunity data that is available. You can learn more trends about like what are the big priorities that would matter to this org across the board. Whereas in a vertical AI company, you would learn more about the performance of each of the components, and the orchestration is a separate job on its own. It's usually like an S&P team or some engineering, some ops plus S&P team that orchestrates that.
Yeah, because like the medical uses that I'm aware of is like a computer program could scan 1,000 X-rays and find the black spot that indicates a tumor way faster, way more accurately than any human can, and in a fraction of the time.
Right, so that's a vertical example. But there's also a horizontal example within the same space, like the speed of patient treatment, right? So there might be something that tracks how long the whole episode takes. And that's a horizontal thing. You could have a program that specifically does that calculation for you. But ultimately that's going to be owned by a person as well, right?
So CEOs and founders have nothing to worry about right now.
Yeah, but I will say it changes the nature of companies, right? Like we were talking about creators being empowered. It's going to be more of a solo gig, right? Like you're less likely to need to staff up as much due to the availability of services that solve a lot of things that were formerly jobs.
Like the one person that I talked about who does 5 times the amount of work.
Yeah.
Because at our rival companies, they have 10 people doing one of this person's job.
Right.
Yeah. Interesting. Cool. Well, glad we got that settled. It's good to hear from an expert. All right. So I guess the other part when it comes to like these type of discussions is how soon before we have like an actual physical functioning robot capable of folding clothes in everyone's houses.
Do they not already have that?
Last I checked, robots can't fold clothes and put them away. They can fold clothes, but they can't navigate the nuances of your house and put them into a drawer.
Gotcha.
They can fold clothes. They've solved that.
They don't have a robot system.
Yeah.
They can do that, right? I mean, as in, they could have a smart home connection, right? So if clothes folder robot will emit a signal once it's done initiating mover robot or specialty Roomba.
So you would need multiple robots then, one to fold the clothes, the other to put it away.
I mean, from a technical standpoint, I'm not deep into this space to know exactly. I think it's feasible, right? But right now we're more on the vertical, the vertical, right? Where each of the robots solve specific jobs. We don't have an omni-functional robot, do we?
No, not the closest we have is Elon Musk's guy dancing around.
Have you seen the Japanese robot dogs?
I've seen the ones from Boston Dynamics.
Yeah,
Spots.
They've been doing that for like 40 years. Sony has been building these like high-end robot dogs. For a long time.
It's frightening because.
But I think Boston Dynamics got sold, right?
I don't know.
I think so. They got. I think Google sold them.
As in, they got acquired by somebody else.
Yeah, I think they got spun out, or they were made independent.
Who would let them go?
Google.
Why?
They mustn't have found a way to make it lucrative. Also, Google is a specific company, right?
Well, is it Google or Alphabet?
Well, we're talking about their M&A strategy, so it's just the same thing.
Yeah. All right. So I mean, so right now I forgot the name of the guy I was listening to. He was on Lex Freeman's podcast. He just dropped it a few days ago. He was discussing about an AI that, because right now we have like the Alpha Star that just plays StarCraft, AlphaGo that just plays Go, Alpha Chess that just plays chess. They're currently working on a alpha game that can play any game that it sits down in front of. So So I don't know how much you know about that development right now.
Yeah, I follow the AlphaGo development. I don't know the background behind the Alpha game. I can think of a couple ways they could do this. They could hope to create one general system that has transfer learning, customized models for each of the games it learns. So meaning, say like it's been trained on 10,000 games across 3 different games, 3 different kinds of games. The idea is that if you make it play game 10,001, it'll actually just apply the general model, or it'll apply, it'll enable learning across the whole system.
Yeah.
So that's the transfer learning enabled, probably a neural net based model. And then there's the other one where it's just multiple models within the model.
I think that's the one that he talked about.
Okay.
Yeah, because right now, like in order to build AlphaGo, they had to create an AI they had to create a neural network that was specific to learning just that game.
Yeah.
But they want to create a specific neural network that could understand games, and whatever it sits in front of it'll eventually play. And in order to do that, it needs. I definitely don't remember everything. It was extremely technical.
Okay.
Yeah. I'll let you expand more about where you think they were going with that, because you'll probably talk about it better than I do, even if you're talking from theory.
Okay. Game theory is a really famous area in general, right? So they built a lot of algorithms in the beginning to solve for different kinds of games, and they even tried to. A lot of AI is actually applied game theory, in my opinion. So when I was in school, I got into AI for that reason. Like I started off as a physics major, and I slowly went towards applied math, and then I liked math sort of applications, and game theory was one of those areas. But I found the mathematical discipline of game theory very speculative. It made horrible basic assumptions that kind of made conclusions that were totally useless in my opinion. But then I learned about simulation through an AI class, and I found the ability to learn through AI and simulation very interesting, because you could get useful outcomes out of that. So that's where I came from. As far as a game for games, I think the framework for it has been there for a while. There's probably a generalized AI a way to generalize a game AI. And then derive different branches for the games as you go out. So I think they're doing generalized AI for games, and then they're having transfer learning for adapting each of the branches. Have you heard of transfer learning before?
I have not. This is
new
territory for me.
Yeah, so transfer learning is creating a model for a different problem based on a trained model for one task. So we were talking earlier about like a folding robot, right? So let's imagine we're going through a scenario of the 2 robots working in tandem, right? So let's say you just trained a robot that has folding down, but you don't have a robot that has the mobility down.
To navigate the house.
Yeah, navigate the house or move the folded thing there. The folding robot might have like a partial training because of the folding action and some of the movement. It might have some information that just transfers over to that model. So you can pre-train the second model just from the folding robot stuff, and then you need to have actual data for the movement added. So instead of building a raw model from the movement, you have some learning from the initial model, and then the process of adding the data to it for retraining corrects it. And you can even learn stuff from the movement piece that actually might inform and educate the initial folding piece.
And then eventually the folding piece will learn how to put it away from the folding.
Better. I'm not saying the folding piece will solve the other problem, but by virtue of these 2 models being related and able to learn from each other, that's the principle of transfer learning.
Oh.
Yeah.
That's very similar to traditional human learning then, because I know something and I teach it to you, kind of like and then you know something, you teach it to me.
Yeah, so you learn a principle in domain X, right? And it actually applies to something in domain Y as well. Or it partially applies in domain Y. You try it in domain Y when you're learning something in domain Y, and you realize it's kind of true, and you learn what worked in that and what didn't work in that. And then if I share that with you, then you can explore in that space of questions, right? I mean, we can learn from each other that way. But that's the idea of transfer learning.
So one of the things I found interesting about that talk was he said that this alpha game program will never be able to play StarCraft, chess, or Go at the same level as the Alpha Star, Alpha Go, Alpha Chess.
Okay.
So if he's correct, and I'm assuming he is because he's that's his space, then this folding close AI that also knows how to put things away, this robot, is not going to be able to fold close as well as the folding close robot.
So, based on this analogy,
okay,
I'm not sure why there would be a lower limit in terms of the learning of the individual models.
Mm-hmm.
It's just that the way it would learn would be different, right? Because you're learning from both systems.
Mm-hmm.
So the order of the learning will be different. So there's a couple of points. The first is when you learn a new discipline, right? There's usually a curve where you become less performant before you become better.
Yes.
Right?
Yes.
So because you're learning, because you're generally learning more information, that might happen to these systems in a different way because the customized game AI is learning vertically, right? Mm-hmm. More information is basically changing its model over time. Whereas the horizontal system is learning from two systems talking to each other. There might be hypotheses passed on from one model or biases passed on from one model that need to be unlearned by more experience, whether from the second system, whether more data is coming from the first or the second system. So it's called the bias variance trade-off, right? And I don't know if you've heard of gradient descent before. Bias variance, it talks about the goal of a model is to get as close to the real prediction, the true value, right? Mm-hmm. And you're minimizing error. But in the process of learning, you might grow that error before you get to the most optimal error minimizing area between your model and the actual reality.
You're just running a bunch of regression analyses till you get as close as to the line as possible.
Yeah, something like that.
Yeah.
So I don't necessarily see why a general system would not be able to build models that have the same performance ceiling, mm-hmm. Because there's technically more information. But I could see that it learns more slowly.
That's probably it.
And the other thing is there's some aspects of games which are generalizable and some that are not.
Yeah.
That's about just the nature of risk and volatility within games. I mean, to give you a concrete example, let's say basketball and running, for example. Mm-hmm. The drivers of those games are very predictable, actually. Like basketball is pretty much a rehearsed sport. Mm-hmm. The novelty is not really about. You don't see innovation in the styles, really. I might be butchering this. I'm basing this off of this book I read called The Sports Gene, mm-hmm. by David Epstein. It's a very good book, by the way. But
I'll be sure to read it.
Yeah, but he was making a point that there are some games that are hard because you actually need to learn continuously in that game. Yeah. So a couple of examples are like art. Mm-hmm. They gave the example of I don't remember the name of the artist. It might have been Rodin. But the idea is that you had to keep on refining your style and evolving in different directions that made you seem like you were continuously failing, even though you were innovating in new directions that integrated the learning you had before. So most of the career looked like you were moving downwards, but once you looked at the whole picture, it was actually developing positively in a general sense. Mm-hmm. So most of that game is actually about discovery and learning, whereas in a game like basketball or running, it's very much about the inputs, right? Like height matters a lot. The net physicality of specific players matters a lot. It is a game that reduces. There's not that much uncertainty. The phrase that this guy used was, "It's a wicked problem," right? There's a lot of uncertainty within some games, and the leaders end up being the people who can maneuver and learn in that uncertainty. Whereas other games are just specific rule sets, and whoever has the best inputs for that rule set wins.
So kind of like a Hollywood movie production where the rules aren't clearly defined.
Yeah.
Yeah. Versus a YouTube podcast, which has a very specific format to follow.
Fair enough. Yeah.
Gotcha. Interesting. All right. Oh man, there was something I wanted to ask you about. Okay. You mentioned biases, right?
Yeah.
If a computer program has a bias, does what does that make us sentient? just to bring this conversation back to the beginning.
Okay, so the machine learning term for bias
is different from a human bias.
Yeah. So this version of bias just talks about error from between the prediction and the reality.
Okay.
Yeah.
And got it.
Yeah. So you can also build models that are purposely biased one way or another. So going back to cancer diagnosis, right? Mm-hmm. It's worse for a patient to hear a positive. To go through to take a diagnostic test and find that there's no risk of cancer when they actually have it. Right, a false negative is more dangerous.
Oh, that's horrifying.
A false negative is way more consequential than a false positive, right?
For sure.
So, cancer diagnostics are very biased towards being quite sensitive towards cancer risk. Right.
So even if it picks up a blot that's technically not cancerous, it's still going to trigger an alarm and let the doctor know, hey, I found something.
Yeah, my point is like a model is basically drawing a line in the sand in very gray area, mm-hmm. and based on the dynamics of the problem, right, to a human in terms of how they make decisions, that the models are generally biased towards what decisions serve the human, or they serve the decision maker more likely. So there's purposeful bias, but the ideal, the perfect world is that there is no bias at all, right? You just get a precise model where there's no error or bias. The predicted value would be exactly reality, right?
But that's not how reality works, because there's always going to be variables.
And because there are gray areas, you need to have you need to make subjective decisions, basically, right? Mm-hmm. So
this is where the human element comes in.
It does.
Because a robot isn't going to be able to, at least not as it functions right now, isn't going to be able to discern from that data set.
It kind of can. I mean, I'd say for most models, there's a pretty analytic treatment for how you detect bias and how you optimize the model. Mm-hmm. But yeah, in the end, for making decisions, human incentives actually drive the direction of the bias. For our utility, right? We built these models in the first place to serve us better in our decision making, mm-hmm. and human decision making is inherently strategic. It uses game theory, and we're trying to solve our actual goals, right? So, it's important to recognize that.
Interesting. So I did read this study once about two AI programs that were built to communicate with one another, and then they developed their own language, mm-hmm. and then they had to cancel, like they had to put a stop to it because they got scared because the AI started talking about things that the scientists could no longer understand, because they're like, imagine if you and I suddenly switched to Chinese and all the podcast viewers are like, what the heck, you know?
Yeah.
Can you tell me more about that? I'm definitely curious.
I mean,
I saw your eyes light up.
Yeah, that class of discovery is one of the motivating lights for researchers in AI altogether. Mm-hmm. So the reason I followed the AlphaGo stuff is that when they pitted the system against the leading Go player, they found that the system created innovative moves that humans have never thought about before.
Same thing in StarCraft.
Yeah,
they had build orders that no one's ever saw. I'm huge into StarCraft.
Yeah. So let's map that against like a risk framework. Have you heard the Donald Rumsfeld quote? There's known knowns, known unknowns, and unknown unknowns.
Yeah.
Right. So not being able to understand the way the machine is communicating with other things is the unknown unknowns. Yeah. And most of the AI systems, like through the 80s, are in that class. But as we sort of understand, one of the goals of researchers is actually to cut down that gap, right? Understand, make the line between how we define models and how the models actually evolve themselves more transparent. So there's been a bunch of work in that space, both from a regulatory standpoint, but from just a general data science and modeling point of view. So yeah, I mean, I've seen different. It's a really interesting problem to crack, I think, and I've seen some interesting progress. I've seen some valuable progress, even in like the common tooling that you see available towards people building black box models. Mm-hmm. There was this thing called there's some services like H2O.ai and Data Robot, which have incorporated these things like Shapley values. In economics, a Shapley value is a way to derive the weight of the importance of specific features within the data set. But they're also, in this case, helpful. Yeah. So the idea is that for these tools, you feed in a model you don't necessarily understand, and you can derive some big picture insights about what are the things that it's weighing in and what is it actually measuring out, without having to feed it in a lot of like manual documentation. So, yeah, I've seen some very cool developments in terms of making models more transparent to humans. I'm also just excited about seeing new routes and things taken by AIs, because it's we don't know what that means. It falls into unknown unknowns, right? So it gives you food for hypothesizing about what that could be and how you might isolate some patterns out of that, which could be helpful for humans.
In 200 years, when we've integrated and we integrated technology into our physical being, and we're pretty much cyborgs, are we going to have like a different? Are we going to develop a completely different language because of that integration? Are we going? Because because at that point when we communicate, we'll probably be part of a giant neural network ourselves, and we can think each other thoughts. And spoken language might be a thing of the past.
I don't know.
I went full Hollywood there for a second.
That's okay. I mean, we're in the age where the metaverse is a popular concept, right?
Man. Do you have any thoughts on the metaverse? on the development there, cryptocurrency, all that stuff?
I think most of the metaverse talk is well executed copy marketing, or PMM marketing, probably driven by Microsoft. I mean, I think there's some versions of the metaverse I believe in. There's some I don't. I believe a lot in the NVIDIA metaverse, the Microsoft metaverse, the Unity, the gaming metaverse. Yeah, those are the ones I think have coherent visions about what they're trying to achieve and how the components are coming together.
What about Zuckerberg?
Right now, I think it's more driven by legal, right? Because they were trying to rebrand what they're about. But right now, most of their money is from advertising from their advertising. Sorry, most of their revenue comes from Facebook Blue and Instagram, successfully advertising, right? So that's the old world. That's not a metaverse pivot. They're investing heavily in it, but there's so much unknowns about how that could happen, and they're also being competed with in terms of the hardware side and also some of the niche experiences you can have. So yeah, I think it's an open question with them. I'm not very bullish on them right now. In terms of making that shift, because it's a huge shift from a company perspective. First of all, they have made that sort of shift with mobile before. They were still
operating in the same space though when they shifted to mobile.
Yeah, exactly.
That's still the same.
They were a software and AI company. The alignment and the organization was kind of there. They just had to make aggressive decisions in terms of the investment and then the restaffing a little bit. But here, I think it's a different ballgame. The other thing, it's not a virgin market. There's been like VR sort of plays for a while. The other thing is biology, right? I like sports a lot. I've been excited about using VR for sports training, safe sports training. One of the use cases I got really excited about was skiers using VR goggles to fix their technique without having to go on a hill, because every time you run, there's a risk of injury.
Yeah. Plus time and everything.
Yeah. So I'm bullish on things like that because that's been a specialized case, but I don't see that hitting the general market. So these are all they're not informed by being a data scientist. That's just a business strategy.
At least not until the headset gets solved, because right now that headset is just big and bulky.
Yeah, and the other thing is biology, right? Like there's only so much time we can actually operate in that space.
I spent half an hour in one of those, and I got so nauseous.
Yeah, I know that I individually could not, because I get nauseous. I have dreams in game graphics if I play enough of like BioShock or those games. When I was a PC gamer, and I realized I just didn't have the physical attributes to to enjoy that modality.
Mm-hmm.
I also don't think it's healthy. Like the way the metaverse is sold, it's not. It doesn't align with health goals so
No.
far.
Well, you don't think that there's a I'm going to be a little bit crude here. You don't think that once they put strip clubs and porn onto the metaverse, that people are just going to flood into there and just create a whole ecospace that way?
They can, but do you think it'll become a general consumer market? I mean, I think just the whole form factor is something that cannot become general market because it's lower. It's hard to access. And one of the best things about the internet from an access standpoint is that you normalize everything to simple form factors that make it easier for the whole population to actually participate. And this is the opposite of that. This is a high-end form factor that even the most expert people can only participate in for a short amount of time.
Well, here's where I see where the future of Web3 and Meta and all that stuff is.
I mean, I would not combine the two either. I think Web3 is its own thing, right?
Yeah. Well, here's where I see it functioning the best is in professional cases where, like, say, like in a courtroom, instead of having to get a convict out or having to move from this specific location, just everyone just straps in. Boom, there's your avatar. Everyone is in the courtroom together.
Okay.
While the person is still in the jail cell.
Okay.
So we save on the transportation cost. It's not a crazy motion. Everyone's sitting there proper. And for legal cases, things like that. That's where I see the biggest.
Okay, but how is that how is that experience better than just doing video camera into the court, having a video feed into the jail cell?
Short of actual just novelty. Well, the other thing is, this is as per Zuckerberg, most of their development space has been like getting facial features correct because like when a conversation between two people, 75% of it is nonverbal. I don't even know if that's a real statistic, but because like body language.
Actually, I believe that too. Like I whiteboard a lot in my interactions with people, so
like raised eyebrows, like those communicate a lot of things.
Yeah.
And just through these little like 6-inch, 7-inch, or 19-inch screens or whatever, a lot of that does get lost in translation. Whereas if you can figure out how to translate that into a meta world, I think that's where the value could lie in changing communication. And I think that's the only case that I can think of right now.
Mm-hmm.
But that's also like a very huge ask.
It's a huge ask, which is not developed at all.
No,
right?
It's not even an idea at this point. It's an idea of an idea.
Yeah, and I mentioned different categories of constraints before.
Mm-hmm.
I mean, there's biology and hardware in this case.
Yeah.
And ultimately, they're trying to string together our laptops, and then they're presenting a UI where now your laptop is, well, with the display, you have even less screen space to actually do work.
Mm-hmm.
So, I don't know.
Yeah.
Anyways, that's our opinions now. I'm sure in 5-10 years we'll look like fools. Who knows?
Who knows? Zuck could be the greatest genius and put Elon Musk to shame. Who knows? or he'll be the billionaire that poured billions into this idea that never reached fruition.
That's okay.
Yeah. I mean,
he has a good legacy.
I think the value is just that he's still trying because through trying these things, you activate Moore's law, and he's going to continue to find new innovations that may not benefit the metaverse or Web3, but it'll benefit other things as well.
Yeah, I do respect him as a founder because first of all, look at it. All the big techs lost their founders aside from Microsoft recently, right? In the last 2 years, they all left.
Yeah.
So
Bezos left Amazon.
Yeah.
Elon is Elon. He does Elon things.
He does Elon things.
Yes.
Yeah. I'm not very positive, to be honest, but okay.
On Elon?
Yeah.
Oh man, we don't have time to
That's okay.
That.
It's a separate thing.
We'll talk about that off camera.
Yeah.
Yes. All right, cool. Awesome. Well, thank you. This has been tremendously informative. I'll be honest, I do feel like I was underprepared, and I do feel like my questions, but that's more of a me thing. Let me not even get into that.
You did a good job. I think there's so much range in terms of where you could go and how deep you can go. So,
Thank you so much for being here. Is there anything else that you would like to say about like future of technology and where we're headed and positive thoughts?
I'm an optimist in general, not just about technology. I'm excited about the opportunities we can create in the future. I think I'm very excited about ability of individual people to use technology, use society to build things for the future.
Awesome. Thank you so much.
Yeah.
All right. We gotta do this again.
Okay.
Yeah.
Oh yeah, absolutely.
Yeah. For sure. No, like when I get